Hello, today we're looking at lesson 310, which is the real numbers. When we're looking at real numbers, we're really focusing on classifying numbers, being able to name them and to name the specific family or number groups to which they belong. So if you take a look at this chart, you'll notice that the most exclusive groups start in the middle. So the group that includes the least amount of numbers is the natural numbers, and they start at 1 and they are every consecutive whole number that's positive. Then we expand a tiny bit to whole numbers, and the only number that's included in whole numbers that was not included in natural numbers is the number 0. So all natural numbers are also considered whole, but the number 0 is considered whole but not natural. And then we expand one more time to integers, and integers now include all natural numbers, all whole numbers, because they also have 0, and they now also include the opposite of all whole numbers, which include the negatives. When we move on then to rational numbers by definition are any number that can be written as a fraction, which basically mean that they are going to be decimals that terminate or repeat. So they either stop or we can determine that they repeat. So a few examples of rational numbers, 1/4 would be a rational number. 0.75 would be a rational number. 0.3 repeating would be a rational number. So any of those are rational. Now, within the family of real numbers, there is also another separate group that exists by itself over here, which is irrational numbers. Those are numbers that do not terminate or repeat, so decimals that do not stop. So famous example would be pi. We know that has an ongoing number of digits that never stops. The square root of any non-perfect square also would be considered irrational. And then over here we have what we call imaginary numbers or not real numbers. And this is going to typically happen when you do something that's mathematically impossible, like take the square root of a negative. Somebody also might consider dividing something by 0 impossible. It can't be done. So those would be your not real numbers. All other numbers are real, and then they're classified either as rational or irrational. Once you know they're rational, they can be several other things, including integers, whole numbers, or naturals. So when you look at example 1 here, what we're asked to do is to write all names that apply and simplify first if you can. Now my recommendation is to start with the broadest name that you can give the number and then work your way in. So I immediately see the square root of 3. That's not a negative number inside the radical, so I know this is a real number. So I'll start with that. Then within my real numbers, I have to identify, is it rational or is it irrational? Well, it's the square root of a non-perfect square, so I immediately know that it is irrational. If a number is irrational, it can be nothing else, so we stop there. Next, negative 9.45 or negative 9 45/100. Okay, that is certainly a real number. It is negative, but it's not inside a radical, so it's real. It is also rational because it has a decimal that terminates. But then we move on to integers, which it is not because it's not a whole number or opposite of a whole number. So we will stop there. Okay, next we see the square root of 16 over 2. Now that can be simplified. The square root of 16 is 4, and 4 divided by 2 is 2. So we're actually classifying the number 2. Well, that is certainly a real number. It is rational because it is not going to be a decimal that doesn't stop, terminate or repeat. It is also an integer, a whole number, and also natural. So there are quite a few names to give that one. Okay, next we have negative 82. That is a real number. It's also rational, and it is an integer. Not natural because it is negative. And then we have 6/7. 6/7 is going to be a decimal, but as you see, it is written as a fraction. So we know it's a real number, and we also know that it is rational, but it's not going to be anything else because integers are only whole numbers and their opposites. Okay, next, in the next set of directions, you notice that all we are asked to do here is to state if the number is rational, irrational, or not real. So we no longer have to give all of the names that apply. So the square root of 17, it is a real number, so I know it's either rational or irrational. When I see that it's not a perfect square, that'll tell me that it's going to be a decimal that goes on forever. So I would consider that to be irrational. Next, 0/6. Well, that's just equal to 0. So don't fool yourself and think that that's the same as dividing by 0. It's not. So clearly it is a real number, and it is rational because it's also considered a whole number. And we can see right there that it can be written as a fraction. Next, the square root of -9. Now this is where we get a number that is not real because it is impossible to take the square root of a number that is negative. So anytime we see that, we classify it as a not real number. Thank you.